moving right along, we're going to do some graphing again. We're going to do some square roots, cube root functions, start kind of basic, do some transformations like we did with parabolas. You'll be just fine. All right, here's our standard F.IF.7B. This is what we're going to get assessed on. Okay, you read that. All right, let's start off with the parent square root of functions. So we have y is equal to radical x. And then let's talk about the domain of this function, okay? What is the domain of this function going to be, right? What's allowed to be plugged in? So hopefully we can see that we can do it in set builder notation. So we can say x will be an element of all real numbers such that x is greater than or equal to 0, okay? All right, so then if that's the case, then what type of numbers are we going to get out of here, right? So if I plug in 0, y is going to be 0. If I start plugging in positive real numbers in here, I'm going to end up with positive real numbers here. So I know that my range here will also be, okay, y is an element of the real numbers such that y will also be greater than or equal to 0. There we have it. All right, so let's take a look. What does this look like? Okay, I already created an input-output table for you. Okay, we know that because the domain and range are positive, this graph is going to live over in quadrant 1. Okay, can't be negative, can't be negative, can't be negative, right? All of these parts have some part that's negative. So let's go ahead and no, it's too big. There we go, that'll work. Okay, so if I plug in 0, I will get 0. If I plug in x is 1, square root of 1 is 1, okay? The square root of 4, right? I'm picking perfect squares. Square root of 4 here is going to be 2, right? So 1, 2, 3, 4, 2. All right, and then we're going to look again. We'll say square root of 9 is going to be 3, 4, 5, 6, 7, 8, 9, up 3. Okay, and if you notice, this is sort of the inverse, right, of when we did x squared, right? It looks like the kind of like a parabola, right, tilted onto its side here, okay? But we can only use half of it based on what we learned about inverse functions, the horizontal line test, about keeping that as a function as well. Okay, so this is sort of only one side of our parabola. Okay, and let's see, will 16 fit in here? Let's see, 9, 10, 11, 12, 13, 14, 15, 16. Nah, it doesn't really fit. It'd be over here. Okay, I can't really get it on there. So let's go ahead and we're going to graph this. And so this is what our function looks like. Okay, kind of like I said, a parabola on its side. Okay, and it's not perfect, but it gives us the general idea of what radical x looks like. Okay, so now let's go ahead and let's talk about let's change this up a little bit. Okay, now what happens if I take 2 and multiply it by x? Okay, and what I want to do here is I'm going to bring up Desmos here, and this is my first this is y is equal to radical x. Okay, that's what's happening here. So I can look here, and I got, what are some of my points here? I've got 1 comma 1, right? Should I get to 4? I got 4 comma 2, right? We got 9 comma 3. Should have 16 comma 4, okay? And on and on and on, right? And I've got 0 comma 0, right? So that's, so far, that's what it looks like. All right, so come on back. Let's take a look at 2x, okay? Well, look at here. This is the original input output table, okay? So don't look at this as being input output table, but this is the original, right? Remember how we solved how we graphed parabolas, where we followed the parent parabola. So let's follow the parent radical function here, okay? So if we start at 0, okay, we'd go 0 comma 0, right? My domain and range is the same. I'm multiplying it after this, okay? So domain is still going to be x is greater than 0. Range is still y is greater than 0, okay? 0, 0. Now, normally what we do is if x is 1, right, we take the square root of that, right? X is 1, y is 1. Now we multiply by 2, okay? So 1 comma 2. All right, and then we looked at if x was 4, y is 2, multiply that by 2 is 4. So 1, 2, 3, 4, okay? And then that's going to be 4, all right? And then if I plug in 9, 4, 5, 6, 7, 8, 9, it would normally be 3, but we're going to multiply that, so we're going to get 6, right? And if I went over to 16, it normally would be 4, multiply that by 2, you get 8, okay? And so that's what this is looking like, okay? And it gives us sort of that same idea of how we worked with parabolas before. So now what we can see on Desmos is that the red line, okay, this is the parent radical function, okay? And you can see this doubles, right? So if I look at 1, okay, this is going to be 2, okay? Go over to 4 and I get 4, okay? And we went over to 9 and I get 6, okay? And on and on and on. And so that's how that one looks, okay? Okay, so now let's move on to this one, okay? So let's look at this one and let's take a look a little bit more at like our domain and range here, right? So the domain here is going to have to be, right, such that x is going to be greater than or equal to 3, right? I can't actually put in anything lower than 3. If I put in 2, I'm going to get a negative number. I can't get that to work, okay? And then, let's see, my range is, if x is 3, I add 2. So my range here is going to be anything greater than or equal to 2, okay? And so we can look here is, this is sort of like a vertex, right? So I'm looking at when x is negative, when x is 3, right? So when x is 3, y will be 2, okay? It shifts this whole thing, right? So it's sort of like I shifted this piece, I shifted it right 3 and then up 2. Right? And now there's no multiplier here, right? There's no coefficient. So we're going to follow this same pattern, right? So I'm going to move 1 away, up 1. Okay? I'm going to move over 1, 2, 3, 4, and I'm going to go up 2. All right? Then I'm going to go over 4, 5, 6, 7, 8, 9, and up 3. Okay? And let's just test it. If I plug in 9, I should get out 5, right? So 9 minus 3 is going to be wait, hold on a second. Nope, sorry, 12. 12, this is 12, right? This is 12 comma 5. Okay, so if I plug in 12, 12 minus 3 is 9. Square root of that is 3 plus 2 is 5. So that works, okay? And so starting here, okay, I'm going to kick out my radical function like that. All right, so let's take a look at what this looks like on Desmos. Okay, so here's what it looks like on Desmos. And you can see it's essentially the same, right? The green one is really just like the red one. It's just shifted 3 to the right and up 2. Okay, so let's go ahead and move on. Let's take a look at cube root functions, right? So I've got y is equal to the cube root of x. So in this case, domain. What is my domain in this one? Okay, so my domain in this one is going to be x as an element of real numbers, right? Such that x, well, it's just that, right? X is real numbers. I can plug in any number in there, okay? Not very good at those. I'm getting better at those, okay? And so then we know that y is an element of real numbers also, okay? Because if I can plug anything in, I'm going to be able to get anything out of this as well. Okay? All right, so let's go ahead and take a look. What does this look like on a graph? All right, so again, I already sort of prepared the input-output table there. All right, so we're just going to graph this. We got if x is 0, the cube root of that is 0. Okay, then I'm looking at -1. Okay, the cube root of -1 is going to be -1, and the cube root of no, that should be 9. Ha, that's totally wrong. Okay, fixed. All right, so next one, right? It's going to go 1. My next cube root is going to be -8, right? So I'm going to go -2, 4, 6, 8, -2, right? And so what would be the next one here, right? What happens if, what is my next perfect cube that I'm going to have to type in here? Okay, so if I'd put another one in there, right, I'd have to go all the way to -27 just to make y drop down to 3, right? And then past that, I'd have to go to -64 just to get to -4, right? Well, once we reverse this, the same is true on the other side. If I go x is to 1, then y is going to be 1, and then I'm going to come over to 8. So 2, 4, 6, 8, pop up here. Okay, and then again, I'm going to have to go all the way over to positive 27 for that to work. Okay, and so what this thing is going to look like is going to kind of come across like this and on and on and on. And then it's going to come up this way and then kind of come all across and on and on and on. Okay, and that's sort of the essential cube root function there. Okay, so let's take a look at what this thing looks like on Desmos. So if you take a look at there, okay, same idea. All right, 0, 0, okay, 1, 1, or negative 1, negative 1. Okay, if I were to come over here, go to negative 8, I get negative 2. And you can see I've got to go real far over there, okay? We got 1, 1. Okay, we got 8, 2. And I'm going to have to go on and on and on. In fact, let's go ahead and zoom out a little bit here. And we can see, let's see, 61. So let's see, 64 gets me to 4. There we go. All right. So we talked about 27. 27 is going to be right about in here. There you go, 3. Okay, and the same would be true over in this area as well. Okay, so let's try another one. All right, negative 2 times the cube root of x. Okay, so again, we're going to start with the idea of the parent function. I left this here, right? This is sort of the idea of what the parent function will look like. We're going to take the result and then we're going to modify it by multiplying by negative 2. Okay, 0, 0, starting there. Okay, we're going to start at negative 1. So if I drop over to negative 1, I typically would get out negative 1, but I'm going to multiply that by negative 2, which is going to push me in the opposite direction. So it's going to push me up here. Okay, if I go over to negative 8, 2, 4, 6, 8, okay, normally after putting negative 8, if I take the cube root of that, I get negative 2, but I'm going to multiply that by 2, which puts me at positive 4, okay? Then we're going to go and basically just reverse it, okay? We're going to do, if I took the cube root of 1, I'd get positive 1 multiplied by negative 2, negative 2. If I were to go 2, 4, 6, 8, take the cube root of 8, multiply by, take the cube root of 8, I get 2, multiply that by negative 2, I get 2, 4, negative 4, okay? And then I can go ahead and kind of throw this out there. Okay, this is going to come down and curve the other way. Kick out there, okay, and that gives us the general idea. Sort of missed one comma 2 there, but that is what it's looking like when you multiply by negative 2. Now, what would happen if I were to, let's say, what would be the next one of the next points? Go ahead and answer that question. All right, so let's take a look at what this one looks like on Desmos. Okay, so the purple line is going to be y is equal to negative 2 times the cube root. Okay, so you can see it's a little bit more extended, right? It's a little bit bigger, right? It's a little bit wider, a little bit more of a stretch there, and it's going to be flipped, right? It goes the opposite way. Okay, let's try this last one. This is going to be that same idea, okay? We're going to look to see where does this thing sort of like start, okay? So before we do is found 0, 0, and we decided that was sort of that idea of where it went, you know, it did that shift, right? Where it came through and made that kind of S, and 0, 0 was in the middle. Well, now it's not going to be in the middle necessarily. It's going to be somewhere else. Well, hopefully what you can see here is you can see that when this thing is 0, it's going to be when X is at negative 5, right? So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5. So negative 5, and then I'm going to go down 4 here. Okay, when x is negative 5, right? If x is negative 5, then y is going to be negative 4. Okay. So negative 2, 3, 4, 5, negative 1, 2, 3, 4. So this is going to be that point from where everything varies, right? It's going to be that sort of center point, what we were doing before, okay? So what we were doing before on a cube root is if I move 1 over, right? If x moves over to the right 1, I'm normally going to go up 1, but I'm going to multiply that by 3. So I'm going to go over to 1, up 1, 2, 3. Okay, now let's go ahead and try that. If I plug in 4 here, right? So I plug in 4. 4 or negative 4. Negative 4 plus 5 is going to give me 1. What's the cube root of 1? 1 times it's 1. 1 times 3 is 3. 3 minus 4 is negative 1. And there it is. That's negative 1. Okay. Same will be true if I go the other way. Okay. So if I'm going to go left 1 from the sort of vertex area right there, and then I'm going to go down 1, but multiply that 3. So I'm going to come down to 3 here. Okay. If I were to move 8 to the left, I normally would go down 2. So we're going to go down 6 from there. So let's go 2, 4, 6, 8. From here, we're going to go down 2, 4, 6. Okay, and we can go ahead and put that there. All right, and then we're going to go do the same idea here. So starting from that middle point again, we're going to go over 2, 4, 6, 8. Okay, cube root of that is 2. 2 times 3 is 6. So then we're going to go 2, 4, 6. Okay, and we're going to go there. And let's keep an eye on this point. We'll keep an eye. This is 3, 2. Okay, and this one was what? Negative 5, negative 4. And we're going to graph this here in a second. And let's just make sure that it looks okay. Okay, and we bring this one up and over and out. All right, and let's take a look at what this looks like on Desmos. Okay, you can see it's the black line here. So let's find some points here. Okay, we got, where is it? Where is it? Oh, it doesn't want to, it's, there we go, negative 5, negative 4. Okay, and what did we say before? It was 3 and 2. 3, 2. Okay, so we're looking pretty good there. Okay. Hopefully you have a general idea of how to graph these. Make sure you bring some graph paper with you tomorrow to class to have a chance to practice.